everybody, today we're going to see this problem, number of visible people in queue. So this is under the hard category. So what this problem state is, there are n people standing in the queue and they numbered from 0 to n minus 1 from left to right. So from here you want to see how many people are there, and you're given array heights of distinct integers where height of I is represents the height of ith person. So this is 10 is height of 0th person. Okay, so a person can see another person to their right in the queue, so to this direction, this, if you can see my cursor movement, everybody in between is shorter than both of them. So more formally it is, let's say the ith person can see the jth person if the I is less than j. So if I is less than j, then ith person can see the jth person, and minimum of height I and j, so whoever is minimum in between them should be greater than height of I plus 1 and I plus 2 and j minus 1. So this implies this is I plus 1, I plus 2, and this is j minus 1 and this is j. Let's say this is j minus 1, this is j. So this way we can conclude, and we need to return the answer number of people the ith person can see to their right in the queue. So it is very easy to predict using common intuition. If I'm standing here, how many people I can see? 1 2 3. 3 is the answer. If I'm standing here, how many people I can see? Right next to me, only one person. So generally I cannot see person who is standing besides, to the right of me, if the height of the person next to me, right next to me, is giant or taller. So in this case, the person to the right of this minion is very short, so his eyesight will continue. If this guy is short, then it will continue. So the common intuition is the eyesight is going to stop when you get the person who is taller than you. Over here the person is taller than this minion, so the eyesight stopped. So this is how we're going to process. So it is very, basic condition is, from, let's say if I start, I want to take care of person to the right of me who is taller. If you can't see this, I'll just copy paste this somewhere in the canvas of Excel. This is very excellent portal to show what I'm thinking. Just delete this like this. Now here is the problem, and we can solve this problem here. So let's say if I have these towers, in terms of towers, this is 10, this is 6. I will draw this 10 much bigger. This is 10, this is, let's say, 6, this is 8, this is 5, 6 and then 5 somewhere here. Eleven should here, and 9. Okay, so more or less this is the understanding. So this guy, whoever, let's say if I start from reverse, because I want only the people. If I start from this right direction, I want to take care of people who are now greater. So if I start from here, this guy is not greater than this guy. This guy is greater. I consider this. Now the next guy is even greater than this guy. So I will only take care of this guy. Once I understand that, let's say, uh, let's say I put this guy. I consider this guy, and then I want to see who is taller than this person. Then, because this is shorter than this guy, so this will conclude the value as 1. Now I do have this somewhere stored over here. I'll just write it this way. Now next is, because I want, why I'm putting this, I'll come to that problem later on. Now I am thinking about 5. So 5 is going to have easy life because 5 is going to see this guy only. So next tallest is this one. So 5 will have easy life. He is going to conclude 1. That's it. Next is this person. So this person 1, then 1, 2. So he will be able to see beyond the person right next to him. So this implies somewhere we need to keep on traversing from this to this till the time we see the guy who is greater than this in height. Okay, so this is 2. Now for this, it is having easy life. Only this it needs to see. So if my intuition, by this intuition if I go, if I just store the greatest number, so this answer should be 1, 2, 3. But that is not the case. We'll have to check with respect to our current greatest number, current number. So if anything which is greater than my current, this is current, if anything is greater than this, I need to only take care of that part. So this means somewhere I will have to store this, then this also. Okay. So actually consider this guy over here and this guy over here. Okay. Now when I check this as a current person, how far he can see? So he can see this person beyond this because he is shorter than this. So he can see this position. He can see this person also because he is shorter than this. Okay. And because he can see this person, he cannot see the person who is over here because this person shadowed this person. Okay, this person. You will be able to see this person only. So somewhere we need to also discard this figure. So if you observe, we are just putting the greatest numbers. Whoever is greater, we will keep it. So let's say first I keep the 9. Now after that I get the 11. Because I got the 11, I will be popping out the 9. I put it 11. After that we see 1. 1 is requiring this 11. So 1 will not do any harm. It will be just sitting over here as a duck. Sorry, this will be 5. Now we go to 8. So 8 thinks that this person to the right is very less than my current 8 number. So what it will do? It will pop this number and discard it. But while doing it, it will record some value as 1. Okay, which is 1, 2, 3, 4. 1, 2, 3, 4. And then it will also look for this because there are two numbers who are in between 8 to its rightest number, so the value for 8 will be 2. Now this is gone because 11 is even greater than 8. 8 will sit like this over here. Now we come to 6. Now 6 thinks that I do have one number which is sitting at top, right next to me, right at the right portion. So it's just one number I need to conclude. So it will say that who is at top of, if I say this as a stack, who is next to this? This is 8. So I will say just conclude this. So it will not remove it, it will just say for 6 this is the height 1. Now we put 6 over here. Now there is a tallest guy, a 10. 10 says what I can see for my eyesight. 10 will say 6 is very, I'll take another color for 10. 10 will say 6 is very shorter than me, I can see it. So 1 number of person I can see. Then it says that 8 is also shorter than me, then I get the count 2. Then it says because this 5 is no longer there, it will go to this guy 11. And now the answer comes third, but our condition, this current number we can reach far to the right till the time my current is less than person to right. The moment this condition occurs, we should stop. This is the stopping condition. Hope you have understood this. What is the intuition behind this? Now coming to the implementation part, we're going to, as discussed, we're going to go by stack approach because we are discarding the numbers as soon as we get something bigger, and we are not putting any smaller number over there. So if the current number is greater than what is at stack peak, then we are going to discard that. In other words, if stack peak is less than the current number, we'll get rid of it. So why we are going to get rid of it? Because we want to compute it, how many people are that way. So because 8 is, let's say, current and stack peak was having 5, we will discard it. Then we will have number of people 8 can see, person of height 8 can see is 1. That will be discarded. Again I'll get the 11. It won't be discarded because current is greater than, current is less than this stack's top 11. So it won't be discarded but will be continued in the final conclusion. So it will become 1 and 1 2. So this is what general intuition behind this, and here is the solution. So what we do, we go from right to left, we keep on checking in the stack. So in very raw terms, need to check how many people in my right have height less than me, current person height. So this is the intuition. Till the time person at the right is having less height than the current person, we're going to pop it, but we're going to count how many such people are, because here is the intuition. He is sitting at the stack, but he is the shorter guy, and he is right to this guy because he is shorter. At stack peak it will be popped out, count is 1. He is also shorter, popped out, count is 2. He is also shorter, stack count is 3. This way we're going to conclude. I'm sorry about this guy. This will be popped out by this one. So one, two, and then we just come to this. So this will be third person. That's why we put it here. So this is the count and this is the next guy. If the stack is not empty, there is someone sitting over here in the stack. So we put it as one over here. So this way we're going to conclude. No matter what happens, we're going to keep adding people at the stack. So this is the problem 1944. This is very good problem, and there are other similar questions. Building with ocean views, sum of sub-array ranges. You should give it a try. It's a monotonic stack problem. Thank you. Have a great day.